Welcome in online tutorials, and today we are continue in velocity. So it is motion straight line and we have velocity today. So simply we already discussed about the speed, and we see that the speed equals to distance over time. So the speed and velocity is quite different. So what is velocity? So if we need to know the velocity is the displacement moved by object per unit time. So the displacement moved by object per unit time. So we may say the velocity v equals to displacement s over time. So this is velocity. So this we call the rate. This we call the rate of displacement because it is per time. It is per time. So we may say that the velocity is the rate of change of displacement. So for the speed, it is the rate of change of distance, and for velocity is rate of change of displacement. So the velocity is a vector quantity. The velocity is a vector quantity. Why? Because the displacement s is a vector quantity. Also, the result will be the vector quantity. So formula for speed and velocity. So the speed and velocity may have the formulas. So let's say formula for speed only, for velocity only. Futa cancel here. Formula for velocity. So formula for velocity will be the velocity equals to displacement s over time taken, that is t, small t. So this is formula for finding the velocity. So continue. We have the note at this. Note. So this is not for you. Speed is a scalar. Speed is a scalar, while the velocity is a vector quantity. So speed is a scalar and velocity is a vector quantity. While the speed is a scalar and velocity is a vector quantity. So let's see at this. For example, at this we have the velocity. So for example, we have the velocity. Velocity, and this is speed. Speed. So we have an intersection. So velocity, the formula is the formula is displacement over time. And speed, we have the speed, let's say v equals to distance over time. So this is a vector. Displacement is a vector. So the result of the velocity also is a vector. But the distance is a scalar. So the result also for the speed is a scalar. So velocity is a vector and the speed is a scalar. So continue. So you have the assignment to do. So you have an assignment to do. Give the difference between speed and velocity. So you may have the difference between speed and the velocity. So this is your assignment. So we have the another things. We have the another terms. So since we studied velocity, we have the other terms used in velocity. So these are the types of velocity or terms used to describe the velocity. The first term is initial velocity. The symbol of initial velocity is u. The symbol is u. So initial velocity is the velocity of a body at the start. At the start is called the initial velocity. So ni ile velocity ya kitu pale mwanzoni kabisa. Pale mwanzoni kabisa ndio inaitwa initial velocity. Another thing, we have the final velocity. We have the final velocity. So the symbol of final velocity is v, capital V. So the v is symbol for final velocity. So final velocity ni ile velocity ya mwisho kabisa. Is the velocity of a body at the end of the observation. At the end of the observation. So for example, we have the car. For example, we have the car like this. You have the car. So the car starting with the initial velocity u and ends with the final velocity v. Ends with the final velocity v. So the initial is symbol u and final is v. So this is initial and final velocities. So another thing to know is the average velocity. Average velocity. So the average velocity is average between initial and final. The average between initial and final. So mathematically, if we need to find the average, we have the initial, that is v, that is u. We have initial, that is u, and final plus final, that is v. So divide by 2. So this is average velocity. Average. So we have the average velocity at this. So this formula we may use to find the average velocity. So sometimes average velocity is the ratio of total displacement to total time. So the ratio of total displacement to the total time. So another thing, we have the uniform or constant velocity. We have the uniform or constant velocity. So the uniform or constant velocity is the velocity one whereby the rate of change of displacement with time is constant. So the uniform or constant velocity ni ile velocity ambayo body inatembea nayo, na velocity hiyo haibadiliki badiliki. Velocity hiyo haibadiliki badiliki. So for example, at the start of the journey, let's say we have the 20 meter per second, and at the end we have the 20 meter per second. Kwa hiyo muda wote velocity imemaintainiwa kwa 20 meter per second. Hiyo tunaita constant au tunaita uniform velocity. So this is constant or uniform velocity. So another velocity, we have the absolute velocity. So the absolute is actual velocity. So the absolute is actual velocity moving by object recorded by the stationary observer. So this is actual velocity. So for the actual velocity, we may say that this is a moving car. So an observer standing at this. So the velocity observed by the stationary observer, we call it the actual velocity. So this is actual velocity. So another velocity, we have the relative velocity. So the relative velocity is a velocity of a moving object recorded by moving observer. So for example, this, let's say for these cars, let's say this is car A and car B. So this is car A and car B. So tuna gari A na gari B. Sawa, tuna gari A na gari B. Na kila moja lina move kwa speed yake. Lakini sasa let's say observer akiwepo katika gari B. Huku kuna observer. Lakini hiki ndo object ambayo tunaiangalia. Hii ndo object tunayoiangalia. Kwa hiyo velocity atakayopima huyu mwenye gari B respect to gari A, hiyo velocity itaitwa relative velocity. Hiyo, lakini condition iliyokuwepo hapa ni lazima ili gari B liwe ni moving, liwe lina move, na gari A nalo liwe lina move. Kwa hiyo tunaiita relative velocity. Na tutaona katika maswali, tutaona vipi relative na vipi actual kwa uzuri zaidi. So velocity nyingine ambayo natakiwa tuifahamu inaitwa instantaneous velocity. Velocity at instant. So we call the instantaneous velocity. So this is the velocity of a moving object recorded at any time. So hii ni velocity ya moving object iliyorekodiwa katika muda wowote ule, Inawezekana kwamba tukasema at a start gari ilikuwa na 20 meter per second, lakini after 2 second tukasema labda likawa na 30 meter per second, labda after 4 second likawa na 5 meter per second. So these all velocities we call the instantaneous velocity at instant. So we call the instantaneous velocities. So these are the terms that we are required to know in velocity. So another thing, so we have the example. We have the example. Let's see this example. A car travels with 20 meter per second in 4 seconds. So we have the solution. Let's say we have the solution. Find the distance traveled by the car. We are required to find the distance traveled by the car. So you have the speed, that is, you have the speed v equals to 20 meter per second. So we are given the time. The time t equals to 4 seconds. So we are required to find the distance, and we know that the speed so required to calculate is equal to d, the distance. So we know that the speed v equals to distance over time. So that is distance over time. So sometimes we may write the x over t. So those are for the distance. So the speed v is given by the distance over time. So we are required to find the distance. So multiply by t both sides. Kwa hiyo zidisha kwa t kila upande. So we have the t cross v equals to d over t times t. So umemultiply kwa t huku, upande huu umezidisha kwa t, na upande wa huku umezidisha kwa t. So the t and t cancels. T and t cancels. So if t and t cancels, so t cancel this. So we have the d equals to t times v. So we may write the d equals to v cross t. So we are given the value of v and we are given the value of t. So now we have the d equals to, value of v is 20 meter per second times value of t is 4 seconds. So the d equals to 20 times 4 is 800. So this is meter. So now we may say that therefore the distance is how much? Is the distance is about 800 meters. So this is your answer.